All right, welcome to our next set of notes, quadratic word problems. Okay, so notes number one, just a quick recap. We talked about standard form, okay, standard form of a quadratic function, and that is ax squared plus bx plus c equal to 0, okay? And so today our focus is story problems. So the key thing is we're going to make sure all of our equations, when we create them, are in the standard form, and then we're going to go ahead and factor to solve. So what we're going to do, we'll go ahead and start number one. Find two numbers. If one of the numbers is 3 more than twice the other number, and their product is 65. Okay, so right off the bat, real important, it says find two numbers. So we're going to have to find two numbers. One of the numbers is 3 more than twice the other number. So we'll write an expression about that. And then the key thing is their product. So back at the very beginning of the year when we were solving equations and we were coming up with them, a lot of times we were not talking about necessarily product, but just like how they were added or subtracted together, one side of the equal sign to the other. So, but anyway, coming back to find two numbers, we have a first number and a second number that we will write expressions for. One of the numbers is 3 more than twice the other number. So we don't know what the other number is. So we'll go ahead and label that as x, and 3 more than twice the other, 2x plus 3. So hopefully coming up with these expressions haven't been too challenging. Then it says their product is 65. So we'll just go ahead and do x times 2x plus 3 equal to 65. Okay? Now we'll go ahead and solve. First step is to distribute. So we have 2x squared plus 3x equal to 65. Next, we'll have it set equal to 0, so we put it in that standard form. So we'll subtract 65 from both sides. And when I do that, I get 2x squared plus 3x minus 65 is equal to 0. I'm going to do the same thing and look for a GCF. Okay, I don't see that I have a GCF, so I'm going to go ahead and factor this. So to get 2x squared, I know I'm going to have an x and a 2x in each of my binomials. Then I have to think about how I'm going to get 3x. So I have to think about all my set factors of 65. So what's kind of nice with 65, there aren't many factors. 2 doesn't go into it. 6 plus 5 is 11. So with 11, I know 3 doesn't go into it. 5 goes into it. 5 and 13. So if I go ahead and do a negative 5 here and a positive 13 here. Real quick, some mental math. 2x times x is 2x squared. Here I get 13x. 2x times negative 5 is negative 10x. When I combine those, I get that positive 3x. And then 13 times negative 5 is negative 65. So that works. Now I'm going to set each factor equal to 0. And I'm going to finish solving. So if I add 5 to both sides, I have x equals 5. Here I subtract 13. And so I have 2x equals negative 13. And then I'm going to divide both sides by 2. I have x equals, I'm going to just write it as a decimal. It'll make this problem a bit easier, negative 6.5. So this is what's different, is now I have two answers. Okay. So with my two answers, I'm going to have to find, there's going to be lots of answers when I solve for x. So one answer when I solve for x equals 5. The other one, I'm going to put 5 in for x and simplify. So that's 10 plus 13 equals, I'm just double checking. Oh, I have 13. No, I made a mistake somewhere. There we go. 13. So this is one answer, 5 and 13. For my other answer, x equals negative 6.5, and then I'm going to put negative 6.5 in for x, then add 3. And so doing the math there, I get negative 10. So many possible answers for that. It says find two numbers, so my two numbers are either going to be 5 and 13 or negative 6.5 and 10. Okay, not all the time will both solutions work. It just depends on the story problem. And you'll see what I mean when we get there. All right, let's go ahead and do number 2. Number 2 says the square of a number equals 9 times that number. Find the number. So this time the number, we're just finding one number. So we'll have, we could go ahead and say let x equal the number. Okay, then rereading this, it says the square of a number equals 9 times that number. So the square of a number, so x squared, equals 9 times that number, and that number was x. And so what we're going to do now is we're going to go ahead and put it into standard form, factor to solve. So I'm going to subtract 9x from both sides. So I have x squared minus 9x equal to 0. Keep factoring. I'm going to factor out my GCF of x, and I have x minus 9 equal to 0. Then we set each factor equal to 0. So x equals 0, x minus 9 equals 0, and then if I add 9 to both sides, I have x equals 9. So my answer is x equals 9 and x equals 0. Can also write it here as 9 or 0. All right, let's go ahead and try the next one, number 3. So number 3, this one talks about two consecutive integers whose product is 72. We've done consecutive integer problems. So it tells us that it's 2. So when I write my expressions, we'll have a first number and a second number. Okay, and when we talk about consecutive, our first number is x, our second number is x plus 1. The story problem says the product is 72, so it's going to be x times x plus 1 equal to 72. And now we'll go ahead and multiply, simplify, and solve. So x, I'm going to distribute. X times x is x squared. Then I have x equal to 72. We're going to put it in standard form, so I'm going to set it equal to 0. So I'll subtract 72 on both sides. X squared plus x minus 72 equal to 0. Okay, and now I'm going to keep factoring. So I'm going to start with how I can get x squared. Well, that's going to be x times x. Factors of negative 72 that add to 7, well, that'll be plus 7 minus 6. Now I set each factor equal to 0. And now I'm going to keep going and solve for x. I chose the wrong numbers. I am so sorry. Hold on. I was thinking 42 and not 72. It would help if I would look at my answer key, right? So 9 and 8, 9 and 8. So now we'll go ahead and subtract 9 from both sides, add 8 to both sides, and just write my answer up here. I have x equals negative 9, x equals 8. Now, both of these are equal to x. So when I do this, if I put negative 9 in for x, and then negative 9 plus 1 is negative 8. They are consecutive integers. My other option is if I put 8 in for x, 8 plus 1 is 9. So I had to find multiple answers to make this work. Okay? All right, let's go ahead and we'll try number 4 together. So number 4, we have two consecutive even whole numbers whose product is 168. So this one is similar to number 3. We have two consecutive even whole numbers. So we do have to remember what whole represents. So we have a first number, which is x. Our second number is it's consecutive even, so it's x plus 2. So to get from one number to the next, it's x plus 2. Now let's go ahead and create our equation and solve. They talk about a product, so it's going to be x times x plus 2, which is equal to 168. We'll distribute and solve. Okay, subtract 168 from both sides. We have x squared plus 2x minus 168 equal to 0. And then from here, we'll go ahead and think of factors of negative 168 that equal 2. That add to 2. So I know I'll have x here, x here. This is where, you know, when you're doing your homework, go ahead, use a calculator, help you out. I don't expect you to know the factors, but since this is notes, I can help you out. I'll tell you that it's negative 12 and positive 14. Then we set each factor equal to 0. And when we solve for x, I have x equals negative 14. And x equals 12. Now this is a case where I go back to that story problem. It says even whole numbers. So I got to make sure both of my answers are even numbers. They are, but it has to be whole. So remember, a whole number, it is include 0 and all numbers greater than 0. So actually, x equal negative 14 does not work because that's not a whole number according to our real number system. So now I'm going to go ahead and find my other values. So if x is 12, then x plus 2 is 14. And now we're done here. All right, let's flip it over, and we'll go ahead and do number 5. So number 5, we have the area of a square is numerically equal to twice its perimeter. Find the length. So, kind of a weird one. We'll have to reread this and think about this, but it does say find the length. So we know that x is going to be equal to the length. That's what we're solving for. It does talk about a square, so we'll go ahead and mention that. Length of square side. It says the area of the square is numerically equal to twice its perimeter. So we really don't even need that word numerically. It's just throwing us off. Area of a square is equal to twice its perimeter. So what I'm going to do here is let's go ahead and draw a picture of a square. We know that all sides of a square are equal. I'm going to go ahead and label them x because that's what we're solving for. Area of a square. So if we think back to area of a square, so area is x times x, length times width, which is also equal to x squared, right? Twice its perimeter. Perimeter is going to be, we add up all the sides, so we have 4 x's. So our perimeter is 4x, okay? And then when we create our equation, we're going to have to remember it's twice that 4x. So let's create that equation. Area of a square, x squared equal to twice the perimeter, okay? Now let's go ahead and try and solve. So we'll go ahead and start by doing 2 times 4x, which is 8x. Next step, we're going to set this equal to 0. So I'm going to subtract 8x from both sides. So again, it's in standard form, as close as we can get there, set equal to 0. Now we factor to solve. So we divide out on x. We have x minus 8 equal to 0. X equals 0, x minus 8 equals 0. I'm going to come on up over here. We'll rewrite x equals 0. I'm adding 8 to both sides, and so I have x equals 8. Now again, we need to kind of just double check to see if both answers work or just one of them. So really, x equals 8 is the only answer that will work. We cannot have a 0 length. So let's go ahead and write that in. No 0 length. Okay, so that kind of makes that part of the problem void. Our square side is 8. And do they tell us a dimension? They did not. So we could call it 8 units on that one. All right? So for number 6, we have a rectangle is 6 meters longer than its width. The area of the rectangle is 16 meters. We're going to find the length and the width of the rectangle. So for this one, why don't we go ahead and start by, it says find length and width. We'll just write down that we have the length to find and the width to find. Rectangle 6 meters longer than its width. Real quick, I'm just going to draw a picture. And the width we don't know. They tell us that the length is x plus 6. So just some quick labels on that one. And then they tell us the area of the rectangle is 16 square meters. So we're going to just remember that area equals 16. I'm going to go ahead and finish labeling my expressions. And area, we know we multiply our length and width together. So my equation for that is my length times my width. Actually, I'm making all sorts of mistakes. Should be width we don't know anything about. And it's the length that is x plus 6. And let's go ahead, just like before, we'll go ahead simplify. So we have x squared plus 6x equal to 16. Set it equal to 0. So it's in standard form, set equal to 0. And then we'll go ahead and factor to solve. And so factors of negative 16, that would add to 6, so that's going to be x plus 8, x minus 2. X times x is x squared. Here I have 8x, then minus 2x, so I know it works. Then we set each factor equal to 0. And I'll go ahead and keep solving. So I have x equals negative 8, x equals positive 2. And with this problem, this is another one where not both of my solutions are working. And hopefully you see that we can only work with x equals 2. We cannot work with negative 8 because we have a negative value. So we cannot have no negative length. And so if my width is 2, my length, 2 plus 6, is 8. Okay, and this time it gives us a unit. We'll go ahead and label that. And that's it for number 6. For number 7 and 8, we'll go ahead, we'll do these together in class. The number 7 is a little bit of another kind of weirdly worded one, like number 5. Number 8 is a good one that I think a lot of our story problems hopefully are more like number 8. Okay, that's it for these notes. I'll see you next time.